April the 2nd, folks, let's go. Start off with some nice expanding and simplifying. It's going to be 15x add 10, 4x add 36, add your x's together, add your numbers together, 19x add 46, let's move on. Next after that we've got a sort of compound area question. So this shape roughly consists of a rectangle and two semicircles. But if you think about it, two semicircles is the same as one circle. So the area of this shape is our rectangle plus a single circle. You then need to know obviously the formulas for that. Rectangle is obviously base times height. And circle is pi times r squared. Now just be careful with your radius. You want half of this 73. Radius would just be from here to here. So it would be 36.5. So we're going to have 36.5 squared times pi for the area of that circle. Put that all together, and we'll get our total area. Yeah, it is quite big. 10,345.9 meters squared in this case. Let's move on. So then we talk about lines being perpendicular parallel. Now remember that to say anything about a line, you need it in the equation y equals mx plus c. So if it's not currently in that setup, you need to rearrange it till it is. And once you have it in that setup, the parallel there, don't want to write that there, the gradient is whatever number is where m is, and the y-intercept is whatever number where c is. So we need to rearrange these. Some of these are easier than others. Line 1, I can just literally divide everything by 2. I can get y equals 4x plus 3. And so that has a gradient of 4 and an intercept of 3. Line 2, I can subtract the x to the other side. That'll give me y is minus x plus 6. So that's got a gradient of minus 1 and an intercept of 6. Line 3, I would have to move the y across to this side and the 5 across to this side. So I'd end up with y equals 4x minus 5. Gradient of 4, intercept of minus 5. So when we're talking about parallel lines, we've already found them. It's going to be lines 1 and 3. And then line 4, just for the sake of completion, you'd want to take away the 4x to start with. So 2y is minus 4x plus 1. And then you want to divide by 2. So y is minus 2x plus a half. So our two parallel lines are 1 and 3, because they both have y equals 4x, so they both have a gradient of 4. If we were looking for perpendicular lines, remember it's negative reciprocal. So 4, negative reciprocal of that would be minus a quarter. There are no perpendicular lines in this list. Okay, describing a transformation. Now, if you're describing the transformation, you should be going through 4 possibilities, which are translate, enlarge, reflect, rotate. And in this case, it should be reasonably obvious that we've got an enlargement here. So, if we want to do an enlargement, what are the things that we need to have? Enlargement, we need the scale factor, which is how much bigger has it got, slash smaller. And we need the center, which is the point that it enlarges from. If you're answering an enlargement question, it's 3 marks. It's 1 for saying enlargement, 1 for giving the scale factor, and 1 for giving the center. So we are going from A to B, which means the shape's actually getting smaller. So the scale factor, you kind of just look at a comparable edge. This is a length of 1 square, this is a length of 2 squares, so it's halved to get from A to B. So our scale factor is a half, or 0.5 if you want. To get the center, you then need to draw some lines from, again, comparable points. So we will pick here and here. And you kind of need to carry these lines on until they meet up with the other lines that you're going to draw. So that would be my line all the way up. And let's pick these 2. If I was to join those together, I would get this point here as being my center. So I can say my center is 1, 5. If you wanted to be extra sure, you could do a third point and see if it meets up at the same situation. So I could do this one here, and that again does meet up over there. Obviously you can do a little bit better with a ruler, but I've kind of just counted those out, and that is where they meet up. So there is my 3 marks for describing that transformation. Secondly, we've got a reflection in the mirror line x equals 5. So if you're doing a reflection, normally I would say this is a tracing paper job, but you can do it with counting as well. In fact, yeah, counting is fine. So firstly, you obviously need to draw the line that we're reflecting in. This is the line x equals 5 because it goes through the x-axis at 5. Then, pick your points. So let's get rid of what I've currently got there, because that's going to get in the way. Pick a point of the shape, and that's 1 square away from the reflection line, so it's going to be 1 square away from the reflection line. This will go here, this will go over here, this will go over here. And this is 3 squares away and in the center, so it'll be 3 squares away in the center. So your reflection would be over here. Cool, that's done. Let's move on to higher. Okay, cumulative frequency graphs. So there's basically 2 or 3 graphs in GCSE that look fairly similar to each other. Cumulative frequency, you've got to identify the word cumulative, and cumulative means basically adding up. Right, accumulate is when you add up things. So you've actually already got your cumulative frequencies worked out, which is good because we can go straight to drawing the graph. But there will have been some numbers here, some frequencies that they started off with. The question is not to figure these out, but I think it's worth talking about how you could go backwards. So there will have been 4 things between 0 and 40, because that gives us a total of 4. There then will have been 7 more things between 40 and 60, which would have got us up to 11. Between 60 and 70 there would have been another 5, and then 6, and then 8. We don't actually need this to draw this graph, but those are where those numbers have come from. It's gone 4, plus 7, plus 5, plus 6, plus 8. Now if you are drawing a cumulative frequency graph, you use this little L shape, upside down I know, as a guide for where you draw your points, because there's a big impetus to try and draw them in the middle of points, but they have to go at the start and the ends. We always start with a 0 point at the top here, so we're going to have a 0 at 0. It's not always going to be at 0, but there will always be a point which is at the cumulative frequency of 0. And then when we get to 40, we go up to our cumulative frequency. Let's get rid of these frequencies. So at 40, we're going to get up to 4. At 60, we're going to get up to 11. At 70, which is halfway between, we're going to get up to 16. At 80, we're going to get up to 22. And at 100, we're going to get up to 30. So just make sure you're careful with matching those up, and then you just need to join them together. Now in GCSE, you're allowed to join these up with straight lines if you want. You can join them up with a curve if you want. They don't really mind. I tend towards trying to join them up with a curve purely because that's what A-level wants. But, you know, dot to dot is also fine. And there's my cumulative frequency graph. If I wanted to read off data, I would read like across from frequencies, or I'd read up from times, depends what the question's asking. But that's all it wants us to do. Okay, interesting indices question. Again, we would assume this is on a non-calculator paper, and we have to be able to interpret these as powers and roots. Remember, for any fraction given as a power, the top is the power and the bottom is the root. And if the power is 1, then there is no power. Essentially, it's just the number. Just the power of 1 is itself. So, let's write this in terms of powers and roots. The first one is going to be the square root of 36 because it's got a 2. The second one is going to be the cube root of 8 because there's a 3 in the root part. And then we are multiplying it by the cube root of 27. That's the root. Power is 2, so squared. And after that, you've just got to simplify. So the square root of 36 is 6. The cube root of 8 is 2. And then the cube root of 27 is 3, but we're squaring it. So we've got 6 plus 2 times 9, which is 6 plus 18, remember your BIDMAS, which is 24. Okay, cool. Remember, if there's a minus, that's where you flip them. Okay, we've got another scale factor question here. And again, remember, we should be thinking LSF squared is the area scale factor, and LSF cubed is the volume scale factor. If you get any idea of writing those down to start with, your life gets a lot easier. So mathematically similar means they're enlargements of each other. The area of the small logo is 20, find the area of the large logo, so we want to know what's the length scale factor. What have we times the lengths by? Well, we went from 4 to 20, and that would mean we times by 5. So the area scale factor, and why do we want that? Well, because it mentions the area of the smaller logo, would be 5 squared, as we've got in the top here, would be 25. So the area of the larger logo would be the area of the smaller logo times the area scale factor, would be 500. Another cheap way about doing this, if you don't like that, would be saying, well, okay, if that's 20 centimeters squared and this is 4, then I could say this is 5, and then I could do the same thing to this side that I did to the 4, so I could times that by 5 and get to 25, and then 20 times 25 would also give me 500. That will not always work, but it does work in this case. Okay, so higher plus. Now we're starting off here with some combinations, and usually with combinations what you wanted to do is multiply different amount of choices together. So for instance, if this just said that Shay goes to an exercise class on Monday and Tuesday, how many options have they got? You would just do 5 times 6 and say there are 30 possibilities. But there is something in this question that makes it a little bit more fiddly, which is that it mentions going on 4 different days, and we've got 5 different days. So we have to think about all the combos of ways that Shay could have gone to the gym in the first place. So they could have done Monday, Tuesday, Wednesday, Thursday. Or they could have done Monday, Wednesday, Thursday, Friday. Or they could have done Monday, Tuesday, Wednesday and Friday. Or they could have done Monday, Tuesday, what's the one I've missed out now? Monday, Tuesday, oh yeah, don't need Monday, do I? So the last option would be Tuesday, Wednesday, Thursday, Friday. So those are like the different days that they could have gone, and then we can get towards like multiplying different choices together. So if they did the first option, then they would have done 5 times 6 times 8 times 8 possible class combinations that they could have done, which is 1,920. And you can do the same thing for the other ones. So for Monday, Wednesday, Thursday, Friday, 5 times 8 times 8 times 10, which is 3,200 possible options. 5 times 6 times 8 times 10 be 2,400. And Tuesday, Wednesday, Thursday, Friday, 6 times 8 times 8 times 10, which is 3,840. And so for what are the total amount of different possible combinations they could have done, it's going to be all of these put together, which would give us 11,360 possible combinations of things they could have done. Normally, I think the thing in GCSE you want to remember is that multiplying different options together. This just had an extra layer of fiddliness. Okay, a bit of trigonometry, been a while. We want to find the length of BD, so we're looking for this x here. Do we need to use everything in this graph? Not really. Okay, so this looks complicated, but actually it's just a sine rule, because you can work out this angle here. 30 and 75 is 105. Take it away from 180, and you will get 75 more degrees. That's 180, take away 105 after all. So let's think about the triangle that we've got there, given we want to find this length B to D. We have got the side that we're trying to find. We've got the angle that's opposite it. We've got another side that we know. We've got the angle that's opposite it. And this is going to be some sort of sine rule question, okay? Because we have 2 sides and 2 angles, and the other 75 degrees we don't even need to use. Now the reason this wouldn't be cosine rule is that for cosine rule you need 3 sides and 1 angle, and no matter what triangle we draw here we can't get 3 sides to be there. So this is sine rule. And you've got two choices with sine rule. You can either have A over sine A is B over sine B, or you can have sine A over A is sine B over B. Now, the thing that you're trying to find should go on the top. So this is if you're trying to find a side, and this is if you're trying to find an angle. Okay, so what do we have? X over sine 30, because that's the opposite angles. Remember, sides are always opposite angles, is 200 over sine 75. So if we want to find X, we need to multiply it across by the sine 30 and say 200 sine 30 over sine 75. This will give us 103.5 meters. Fair enough. But then there's other parts to it, which means we might need to do other things. So the next thing we need to do is we need to find BC. So we've got X now. Let's write that on. BC, let's call it Y. And we need to think about probably this triangle here on the left, on the right rather. And the only other bit of information we can get for that triangle is that we have 105 degrees here. So let's draw that out. We have got a triangle, 60 meters here. We've got 103.5 here. We've got 105 degrees here. And it's Y that we're trying to find. So this is definitely three sides, one angle. This is definitely cosine rule. In cosine rule, it's that A squared is B squared plus C squared minus 2bc cos A. Okay. Probably worth labeling this sort of stuff. Remember, always the angle is obviously A and the side opposite is A, and the other two can be B and C in any order you like. And then it's just put those into the formula. So we'd have y squared, which is the thing we're trying to find, is 60 squared plus 103.5 squared minus 2 times 60 times 103.5 times cos 105. Okay, let's type that in. That gives me y squared is 17,526.8, but I need to square root it because it's the side that I'm actually after, so y is 132.4 meters still. Cool. And then our final one is that we want to find angle CBD, which is up here. Let's call that theta. Now we've worked out y is 132.4. How do you want to do this? So this is probably going back to a sine rule again, because if we think about the triangle that we've got now, we actually know, well, 3 of the sides and 2 angles. I guess we could do this with a reverse cosine rule, but sine rule is always easier to use, so I'm going to try and use that if I can. I've got the angle theta, and I've got the side 60. I've got the angle 105, and I've got the side 132.4, and as long as you've got like 2 sets of sides and angles opposite each other, you can use the sine rule. We're going to use the second option this time because it's an angle that we're after. I guess we should label them up. So there's A, and there's A, there's B, and there's B. So we would have sine theta over 60 is sine 105 over 132.4, and then if we want to get sine theta on its own, we multiply across. So 60 times 105 over 132.4. This will give us sine theta is 0.438, and then remember you have to use sine the minus 1 of that to get the actual angle, and that's going to give us 26 degrees, or 25.96, but we'll round it. Okay, cool. So yeah, you've got to bear in mind your 2 possibilities: sine rule, cosine rule, different versions of the sine rule, and when you use what. Okay, finishing off with a density question. So obviously really important that you know your density triangle, MdV. I've had that remembered using the word medieval. I've also had it remembered using the words Mr. Divine. Whatever works for you. And then you want to match up units. So these are all grams per centimeters cubed. Most of these are grams, so we'd have to think about this as being grams as well. Let's say it's 1,000 grams. Okay, so then mix to make liquid D, we want to know the density of liquid D. Now if we want to know density, according to our triangle, we need to do the mass of the thing divided by the volume of the thing. So what do we have? Do we have all of the volumes of the thing? Do we have all the masses of the thing? No, we don't. So we're going to need to do some working first. We do have all their masses, we just don't all have their volumes. So we're going to need to work out the volume of A and B and C separately, add them up, and then use that. You can't just add up the densities and divide them by 3, I'm afraid. So we're trying to find volume in every case, so that's going to be mass divided by density. So mass for A is 200, density is 0.9, which is 222.2. For B, mass is 1,000. Remember, we want this in terms of the same units as the density, so if the density is grams per centimeters cubed, we need to go to grams as well. That's 714.3. And then for C, the volume of that is 500 over 0.75. Might actually be the biggest one. 666. 6 recurring 0.7. So let's put all those three things together. Let's get an overall mass for our object. And we'll get that its overall volume, 1,603.2 centimeters cubed is the volume of D. So to finally get the density of liquid D, we're going to do mass, which is all these masses added together, so that'll be 1,700, divided by volume, which is all these volumes added together, which is 1,603.2. That will give us an overall density of 1.06 grams per centimeter cubed. Cool. So yeah, just a simple triangle for that one, but then you've got to make sure you're using the right things in the right place. You'd have a look at that and think, is that a sensible density to get? It is somewhere in the middle of these three, so it's not bigger than 1.4 or less than 0.75, which would be a real warning sign. Okay, see you tomorrow. Cheers.